Let's take a look at the quotient of powers rule. So now we're going to be dividing. Quotient means the answer you get when you're dividing. The quotient of power rule, as written in your book, looks like this. A to the m divided by a to the n. And once again, notice that the bases are the same. The bases are both a. So we've got the same bases here, same bases. And as for the other two rules, it's really important that you make sure that you have the same base. If you don't have the same base, this rule doesn't apply at all. And it may be no surprise to you that when we were multiplying, we were adding exponents, that now that we're dividing, we're going to be subtracting the exponents. So the quotient of powers rule says take the top exponent, the exponent in the numerator, and subtract the exponent that is in the denominator. So my answer is going to be a to the m minus whatever n is. And I'll use the example that they have here in the book. Well, let's just do some positive exponents here. We haven't really talked about negative ones yet. I'll use the same base, though. So 6 to the 10th divided by 6 to the 8th would be 6 to the 10 minus 8, or 6 squared. Why that works is also pretty easy to see. Let's choose a smaller set of exponents. What about 5 cubed divided by 5 squared? If I write out what this actually means, 5 cubed in the numerator is 5 times 5 times 5, right? I've got 3 5s. And in the denominator, I've got 2 5s, 5 squared, or 5 times 5. So a lot of times when you're looking at simplifying a fraction or simplifying a division problem, you think about canceling out like numbers, right? 5 and 5 and the top and the bottom can cancel out. And we could say, oh yeah, they leave us with a 1 when we divide them. And there's another pair that I could divide out and have a 1 and a 1. And what's left in the top is 1 times 1 times 5, or plain old 5. And 1 times 1 in the bottom is just plain old 1. And 5 divided by 1 is, of course, 5. But the shortcut is to remember that I could just subtract the exponents. So 5 cubed minus the 2 squared is 5 to the 3 minus 2, or 5 to the first. And of course, anything to the first power is just itself, 5. So there's the quotient of powers rule. Same thing is going to be true if I have variables. Let's put one together that has two different variables, maybe x's and y's. How about x cubed times y to the 8th divided by x times y to the 5th. So I just need to make sure that I'm subtracting the exponents of the bases that are the same. So I'm going to subtract exponents from x's differently than exponents from the y's, because there are two different bases that we're considering here. So let's do the x's first. So that'll be 3 minus 1, right? We've got a little invisible 1 right there. And then the y's will be 8 minus 5. And our final answer will be x, 3 minus 1 is 2, times y, 8 minus 5 is 3. So x squared y cubed is our answer. And once again, if that the rule is not making a whole lot of sense to you, let's just write out what this actually means. So x cubed is x times x times x, and that's over 1x. And y to the 8, that's 8 y's. Y times y times y times y times y, whoosh, times y times y. That's a lot of y's. You see we've got a rule. I think I even have too many y's here. I should have 8. 1, 2, 3, 4, 5, 6, 7. Oh, amazing. Right number of y's. And then 5 on the bottom. 1, 2, 3, 4, 5, y to the 5th. And then we'll use that crossing off, the canceling out process. So there's some 1s. I've got 2 x's left. Yep, sure enough, there's the x squared. And cancel out some y's. I've got a bunch of 1s. Remember, when you're dividing out, they don't go away. They just turn into 1 right? Anything divided by itself is just 1. So they're not disappearing. They're just turning into 1. And what happens when you divide or multiply by 1 is that you don't see a lot of net change, right? It just keeps the values the same. Yep, there they are, my 3 y's that are left, y cubed. So yay, that rule really seems to work. In the next video, I will explain about zero exponents and negative exponents, and then we'll do some of the samples at the back of that chapter. So see you in the next video.